Okay, one more type of problem with our non-standard normal random variable x, and now instead of finding area, we're going to actually find x. So, again, here's the information we need. X is normally distributed. Those are key words. We have given the mean and the standard deviation. Now we want to find x. Notice how it says find x. And we have an area value so that we have a certain percentage. So once again, mean in the middle. 70% of the curve is below this x value. That's more than half the curve. So the x value we're looking for has to be up here somewhere so that the area below it is 70% or 0.70. So it's the same thing we did in our other pencast with standard normal. This is an inverse norm procedure. The area to the left is 0.7. The mean is 100. The standard deviation is 5. Exactly as we did with our standard normal. So we want inverse norm, 0.7, 100, and 5. And we get a value of 102.62. And that is this value right here, 102.62. We could get the z-score, which is what we did earlier. We could get the z-score and then use that z-score to then convert it to an x value. But the calculator does that for us, so we don't need to bother with that. Okay, now you're going to have questions like this where we want a percentile. So you're going to have to refresh on what a percentile represents. If we have the 60th percentile, that means 60% of the data is below this value, and we have 40% of the data that's above the value. Okay, so 60% below, again, more than half the curve. It's going to be pretty close to the mean. We're going to have 60% down here, and 40% will be up here. We don't need that. We just want the area to the left because we're going to use inverse norm, and it always wants the area to the left and the mean and the standard deviation. So that makes sense. This value is a little bit smaller because it's a little bit closer to the mean. It's 101.27. That's the x value. The last kind of problem that you usually encounter in the homework, and the others are all just variations of this. They feel different than I would reread because they're all essentially these three types. We saw this earlier in our pencast with standard normal, where now we have 80% of the curve here. And if you remember, we got the z-scores in that case, but now, again, we're talking about x. We're talking about x. So, if you remember in the first pencast, I said that those z-scores would be the exact same number, but just a positive and negative. That's not true here, because our center point is not 0, it's 100. One of the numbers will be less than 100, and the other number will be greater than the 100, and they'll be the same distance from 100, but they won't be the same value, positive and negative, like before. So once again, I need the area to the left. So you can either find, you're going to have to find both, so it's not going to matter. So if we go here and we look left, the area to the left of this x value is 0.9. Once again, that's because we have 10% in each tail. The area to the left of this x value is 10%, or 0.1. So we're going to have to do two inverse norms to get these two x values. We have to do both. We have an inverse norm with 10% to the left, and we're going to have an inverse norm with 90% to the left. So this first one is 93.59, and the next one is 106.41, and those are the two x values.